Yeah, hello, let's move on to complete the challenge problem of the chapter 18. Okay, so now it's the trigonometry. So now, okay, so the trigonometry tells us the ABC. Okay, then we have the A, B, and the C, right? So what we have is the okay. So what we have is the triangle ABC, right, is equal to half of the A times B sine C. Okay, so the AB and its angle is sine C. Yeah, let's see how we can prove it. Okay, so the AB sine C, right, means if we can land a height here, this is the height, right? So the H is B times sine C, right? Okay, so that's why the triangle ABC is half of the AHA, right, is equal to half of AB sine C. Okay, and so we know the law of sine, right? Law of sine tells us the A over sine A is equal to B over sine B is equal to C over sine C is equal to 2R. This is the radius of the circumcircle of the triangle ABC. Then now we have so the ABC is equal to half of the A times B sine C. Then sine C is also equals to the C over 2R. So that's why it's ABC over 4R. Okay, next. So here the problem is we have two rays with a common angle. We have constructed 30 degrees, and the point A is on one of the ray and the point B is on the other of the ray. For example, we have the AB equals 1, right? We want to see what's the maximum possible value of the OB, right? So let's see, this angle is alpha. Now we know that's the law of sine, right? We know 1 over sine 30 degrees is equal to OB over sine alpha. Then you can see the OB is equal to the 1 over sine 30 then times the sine alpha, right? The biggest sine alpha is the 90 degrees, right? Means when it is 90, it's the biggest one, so it's 1 over sine 30 is 2. Okay, so next is so how many triangles have an area of 10? So let's see. Okay, so we have the two coordinates is the -5 of 0 and the 5 of the 0. So the base length is 10, right? So if we want to have an area of 10, then half of the 10 times the height is equal to 10. Then we see h equals to 2. That means h equals to 2 means the x, y, o. That means the y equals to 2, right? So all the points should be on this one, right? On this height. Now we can see, okay? So, and also they need to be all the points, okay? All the points on this line will be have a satisfy the area, right? But the 5 cosine theta and 5 sine theta means 5 cosine theta square plus 5 sine theta square means it's 25, means it's also need to be on a circle with the radius center at 0 but with the radius of the 5, right? So here is the 0, 5. So you can see I have possible I have 4 possible points, right? Also y equals -2, so 1, 2, 3, 4. Oh, sorry. So that's why this is 4, okay? So next, okay, so we have a square. Then we erected the three triangles with four triangles with 30. Erected 30, 60, 90. That's four triangles here. Then we connect A, B, C, D. We want to calculate the hypotenuse of each triangle have a length of the 2. So each triangle has the length of the 2, right? So we know this is the 1, this is the 1, then this is the root 3. Okay? Then what is the outer vertices of this triangle connected to show the quadrilateral ABCD? Okay, so now we can see 90, 90, 90, right? I'm sorry, 90, 90, 180. This is 30, right? So this is the 150, right? So we know it's 2, 1, 150. 2, 1, 150, 2, 1, 150. Okay, so all the triangles, all this white right triangles are congruent. Okay, so that's why, or you can also, I'm sorry, all these shaded triangles are congruent. So that's why you can see AB equals A, BC equals A, CD equals A, AD also equals A. Okay, so then you can use the law of the then you can try to use the law of the cosine, right? On any of the shaded triangles, right? So you can get it is the you can solve the a square is equal to the 1 square plus the 2 square minus 2 times 1 times 2, then cosine 150, right? Then it's the 5 minus the plus the 4, right? And 2 root 3 and equal to 5 plus 2 root 3. So now we use the a square. If you calculate the a square, right, and then you can, next step is trying to calculate for the four shaded triangles. Okay, as triangle shaded is 4 times the half of the 2 times 1 times sine of the 150 is equal to the 2, right? Okay, so now you know the shaded area, right? So the shaded over the big square is equal to 2 over 5 times 5 plus 2 root 3. Okay, you can try to simplify that. Next, so in a circle centered at O, okay, has the radius of 1. Okay, so we have a radius of the 1 and contains the point A and B. AB is tangent to the circle at A. Okay, so AB is tangent. So this is the B. So this is the center of the O. Now we know A is tangent point, so it's 90. Then we connect it with the AOB. Then if the AOB is a theta, right? Now suppose that C is on OA, and such that the BC can bisect ABO. Okay, so BC can bisect angle this. So this is the alpha and this is the alpha. Okay, so now we can see, because this one is 1, right? Now the AB over 1 is tangent theta, so the AB is tangent theta, then the BO is 1 over cosine theta, right? So by angle bisector theorem, right, we know the AB over BO is equal to the AC over CO, right? So now we can get is tangent theta over 1 over cosine theta is equal to, let's see, the OC is x, this is a 1 minus x, is equal to 1 minus x over x. Then we can see the sine theta is 1 minus x over x. Then let's solve the x is the x equal to 1 over 1 plus sine theta. Okay. Next is if we know the sine x is equal to 3 cosine x, okay? So sine x equal to 3 cosine x, and we also know the sine square x plus cosine square x equal to 1. Then we can replace the sine x with 3 cosine, right? So it becomes the 10 cosine square x equal to 1. Then the cosine x equal to 1 over 10 plus minus, right? So then the sine and the sine x will be equal to the plus minus 3 root 10, right? So when cosine x is positive 1, it's positive 1. So that's why the sine x times the cosine x is equal to the 3 over 10. Okay, so we have a line intersect the x-axis at angle 50, and the other one is angle 140. 140 is also the 40 degrees, right? So with the x-axis, the intersection of the L and the K has a y coordinates of the 10. So that means we have the point of the 0, 10, and when is the L is the 50 degrees. The L is the 50 degrees. The K is the 40 degrees. So this is the K. This is the L. Is the 50 degrees, right? So it's 10. So now we know this one over 10 is 10 over this line is tangent 50, right? So this one is 10 over tangent 50 degrees, okay? And this one is 10 over tangent 40 degrees, right? So the P and the Q could be the 10 over the tangent 40 minus the 10 over tangent 50. That's one possible case, right? There is another case is the 10, 0, and 10. So one case is we have the 50 here, and we have the 40 here, right? So on the other case, you can see this is the 10 over tangent 50. This is the 10 over the tangent 40, right? So we have the 10 over 1 over the tangent 40 plus 1 over the tangent 50. Okay. Next. So the right triangle has an in radius of 1. Okay. So we have a right triangle. Here is the A. So if you see the 12, 13, right? It's very, if you are sensitive, it's 13m, 12m, and 5m scaled by m. This is the right triangle. Okay. So find the length of the hypotenuse of this one. So we know the incenter is. So you can see this is the R, this is the R, right? And based on the incenter, here is the tangent point, right? D, E, F are the tangent points. So this one equal this one equal this one. So that's why you can see the AC plus the BC minus the AB, right, is equal to the 2R. So now we can see the 12m. Now we can see the 12m plus the 5m minus 13m is equal to 2. Then we can solve the m is equal to the half. Okay, once m equal to half, then we know the hypotenuse is 13m is 13 over 2. Okay. So next, so what's wrong with this proof? Let's see this proof. Okay. So suppose what's wrong with this proof of the AA similarity? We want to prove the AA similarity, right? Suppose we have these two angles are the same. Okay, so this is the ABC. This is the CDE. You think if you already know the two angles are the same, they already similar. So you basically you assume the similarity is already there. You already you assume the similarity already true, right? Then you go through the law of sine to prove it. What's the point? Next, so we have the ABC on the circle with the diameter of the 1. So with the diameter of the 1, let's put the center here, okay? So that means the radius is 1/2. Then the x is on the diameter, and we have the bx equals cx. If bx equals cx, means the AD is on the perpendicular bisector BC, right? Means the AD perpendicular bisector the BC, okay? Then 3BAC is equal to BXC. So BXC is 36, right? So the BXD is equal to CXD is equal to 18, right? So then we have said the BAC is equal to the CAD. BAD is equal to the CAD is 6 degrees. So here is the 6, right? So now let's see, okay? We have the O, we have the X, and the BAD, okay? So this is 6 degrees, so this is the 6 degrees, this is the 12 degrees, and this is the 18 degrees, right? Okay, so now we need to solve the AX, okay? So this is the half, this is the half. So the AX is equal to the half plus the OX, right? And the OX, how to solve the OX, okay? Let's see. So we know this angle is 6, okay? So that means in triangle OX over sine of the 6 degrees is equal to the half over the sine of the 18 degrees, okay? Now we can solve the OX is sine of the 18 over sine 6, okay? Now we solve this. Now let's do the, so the AX is half plus the sine of 6 to sine of 18. That is equal to the 2 sine of 18. That is the sine 18 plus sine 6. Sine alpha plus sine beta, sine alpha plus sine beta, right, is equal to sine alpha plus beta over 2 cosine alpha 2 times minus beta over 2, okay? So this one is equal to 2 of the sine, add together is 24 divided by 2 is 12, then cosine of the 12 divided by 2 is 6, and the 2 of the sine 18, then cancel, so it's sine 12 cosine 6 over sine 18, okay? See, this is exactly what we need to prove. Next. Let's see the problem. So the object moves 8 centimeter. AB is 8, and turn an angle of alpha, right? And moves 5 centimeter. And to the C. Okay, so we want the AC less than equal than 7, right? So now we can think what is the angle alpha, right? So this is the 180 minus alpha, right? So now let's see the AC squared, law of cosine, okay, is equal to the 5 squared plus 8 squared minus 2 times 5 times 8. Then cosine of the 180 minus alpha is equal to 25 plus the 64, then minus the 80 cosine alpha. Okay, so let's try the limits. So 49 is equal to 89 plus 80 cosine alpha. That means the cosine alpha need to be negative 1 over 2. So alpha is 120 degrees. Okay, so you can see your alpha need to be bigger and bigger to make AC smaller and smaller, right? So the alpha range should from 120 to the 180, right? So this one is the range is the 180 minus 120 over the total range, right? So it's the 1/3. Okay, so the last question. So we have a equilateral triangles, okay, and we fold the APQ along the line PQ, right? So we have a PQ line and we fold it. That means that the symmetry line is here, right? PQ is the perpendicular bisector of this. So this is the A prime. Okay. Then we have this is the BA is 1, AC is 2, means the side length is 3, right? So if it is M, this is N, this is M, this is N, this is the 3 minus M and 3 minus N. And also this is the 60 degrees. Okay, so we want to solve the PQ. Okay, so now we have to try to solve in the triangle of the PQA prime. Okay, so now let's parameterize this. Okay, so we have the 60 degrees, we have the angle of alpha, then we have the 120 minus angle of alpha, then we have 60 degrees. Here we have the 120 minus alpha, and then we have this one is we have this one is alpha degrees. Okay, so by the similarity, okay, so the 120 m over sine of the 60 is equal to the 1 over sine 120 minus alpha 3 minus m over sine alpha. Okay, the other one is the 3 minus 2 2 over sine alpha is equal to the 3 minus n over sine 120 120 minus alpha is also equals to the n over sine 60 degrees. Okay. So in this case, we can see the 2 is to the alpha, and the n is to the 60. Okay. So triangle. Let's see whether we can get something. Okay. So triangle QCA prime is similar to triangle A prime, B, and P, right? So 2 over n is equal to the 3 minus m over m. Okay, seems the similarity may not help us a lot. Okay, so it seems that we have to use the trick. We have to try to solve the trick. Okay, so now let's see this angle. So this angle, because we know these two are similar, right? So this angle is half of the 180 minus alpha. So this one is 90 minus alpha over 2. Then this one is the 180 this one is half of the 60 plus 2 is 30 plus alpha over 2. Okay, so now let's see this one. Okay, so from this one we know the m over sine 60 is equal to 3 minus m over sine alpha is equal to 1 over sine 120 minus alpha. It also equal to these two add together, right? And these two add together. Okay, so it's 3 over sine 60 plus sine alpha. Now this we can construct the equation to solve the sine alpha here. Okay, so now let's see. So the root 3 over 2 plus the sine alpha is equal to 3, then sine 120 root 3 over 2, then cosine alpha minus cosine this one is sine alpha. Okay, now let's try to solve it. Is we have the root 3 over 2 is equal to the 3 root 3 over 2 cosine alpha, right? And plus 1 over 2 of the sine alpha. Sine alpha, okay? Now if we assume that the sine alpha is equal to x, now the cosine alpha is equal to 1 minus root of the x. Now we can do the, so we can from here we can see 1/2 of the x square is equal to square of the 1 minus square. Okay, so now you can get it is the 28x squared minus 2 root 3x minus 24 equals to 0. Then we can see the final answer is the x equals to the 28 then root 3 plus minus 16 of the root 3. 15 of the root 3, okay? Because x should be greater than 0, right? Yeah, sine alpha. So alpha is a acute angle, so you can see the sine alpha is equal to x is equal to 16 root 3 over 28 is equal to 4 root 3 over 7. Okay, then we can solve the cosine alpha is equal to 1 over 7. Okay. Now once we solve the alpha, and we also to use the law of sine, right? We want to use the law of sine for triangle PQA prime, right? So PQA prime in triangle PQA prime, okay? We have the PQ, what we need to know, over sine 60 is equal to M sine 90 minus alpha over 2 is equal to M over cosine alpha over 2, right? So we need the M and the cosine alpha over 2, okay? Because we already know the sine alpha and the cosine alpha, now we can solve the M, okay? Let's use the M here. Let's use this one to solve the M, okay? So M over sine 60 is equal to, so we have the M over sine 60 is equal to 1 over sine 120 minus alpha is equal to 1 over the sine of the 120 root 3, then cosine alpha plus cosine of the 120, right? And the sine alpha. Now you can apply the sine alpha and the cosine alpha into here, right? Now you can solve the M, okay? So you can solve the M is equal to 7 over 5. Okay, now you solve the M equal to 7 over 5. Now you can, let's try to solve this. Okay, so PQ is equal to sine 60 times the M over the cosine alpha over 2, right? Okay, let's solve the cosine alpha over 2. So cosine alpha is 2 cosine square alpha over 2 minus 1. Then we know this is 1/7, right? So it's so cosine alpha over 2 is equal to 2 over root 7. Okay, so now we solve everything here. So 2 root 3, then 7 over 5. Now we have 2, 7. Okay, so the final answer will be 7 root 21 over 20. Okay, that's it for the challenge problem of this chapter. Thank you.